Hey everyone. So today I brought you a promise, which we will see whether it turns out to be true or not. I'm Péter Wilcsinszky. I work at Axoflow. We specialize in log management. We have maintainers in the syslog-ng project and in the logging operator for Kubernetes. So it's not a marketing session, but to understand our use case, just a few words about Axoflow, the product we build. It's a nice log management dashboard that helps in the observability needs of your logging infrastructure, helps with management and a lot of other things that is essential for handling large volumes of logs, being it on traditional infrastructure, VMs, but also on cloud-native Kubernetes, of course. So our setup is quite typical. This is, as I said, a dashboard. So it has a UI, which talks to a backend that translates the API calls to this UI. And this API is the central part of the solution, the agents, which are running on hosts that produce logs or Kubernetes clusters, or talk to this API, which I already talked about in a previous session. This is KCP, and it was a separate talk on its own. We also have a bunch of controllers that works against this API, which is a declarative API, similar, or actually it's Kubernetes without the pods and services. But the point is more about how we wanted to start in the beginning. We started not a year ago, half a year ago, and the goal was to be able to iterate as quickly as possible. So we started to sketch up ideas and started the implementation with the UI. And in a few weeks, we needed something to run it and to be able to develop, start developing the backend on it. Actually, the biggest problem was how to name the backend, but I don't get into these details. So I started to look into how we could solve this the most simple way. I already worked with Scaffold, but I didn't really have good experience with it. So I started to look around for other tools as well. The goal was to be able to efficiently develop locally, run everything, spin up everything on a local machine, be able to deploy it somewhere. That was in a later stage, of course. But be able to integrate on a remote cluster, to be able to see whether the thing works in the cloud, not just on our machine, and then to be able to take a step even further to deploy the whole thing on a demo environment. So typically, mainline or main or master branch goes to dev, and a tag goes to a demo environment. But also it is very important, as we would like to produce environments, protected environments for preview. That should be easy as well. So as I was looking, I already heard about Garden. So I wanted to give it a shot. And it felt really nice from the beginning. So I started to look into how the configuration looks like, look at the Quickstart, and of course started to play with it. And I think it's maybe better to show how it looks and feel in real code. So, yeah, of course. If I remember how to zoom, I always forget the, no, not that one. Yeah, so there's a global configuration of Garden, which is called Project Garden YAML, and there are separate snippets of configuration that are all merged together when you work with a project that builds up of multiple components, which is the typical use case. So we are not a typical microservices shop, as I showed you. We have a few components, but not that much that it would be worth to break up the backend or the API into multiple services. So, but still, these components have to live somewhere. This is the Quickstart that Garden has, so it's not our project, but to be able to, I don't know, show how it looks, it's good enough to see. So the first thing is that this project allows you to define some variables, global variables, but most importantly, the environments that you want to work against. So local environment, which you have on your local machine, and remote environments, one or more, as you see fit. And as you see, this is the place where you can add your environment configuration as code. So this is the single place that holds all the environments that you want to manage at a central place. You can also configure your providers. This is typically local Kubernetes. So on you want to run it on Minikube or Kind, which is your favorite. It depends. And on ephemeral Kubernetes is something I will talk about a bit later, but on remote Kubernetes clusters typically. So it's just a matter of time. You start working locally, and very soon you will want to deploy to a remote environment. So that's it. That's a project configuration. And let's see what else we have. So in case you have, this application is a voting application, a simple example application. It has a worker component. And this worker component is actually a Java project. It has a Docker file, some Java sources, and the POM XML. The point is that this is familiar things. So these are familiar things. So you have a Docker file. You build your project. You don't really want to do anything else in the beginning. The best would probably be, because in the beginning we didn't really want to write Kubernetes manifests. So not because we hate it. It's not our focus. We don't even know where we want to run it. So it's just a Docker file, and we just want to spin it up and see how it integrates with other components. And Garden makes this possible with an abstraction on top of Kubernetes that you can use. So as you can see, these are two actions. The first is a build action that builds a container. Easy enough, uses the Docker file and builds a container. And the second one is still a container type, but a deploy action, which will deploy this container somewhere. Where it depends on which environment you want to use. So you don't have to tell anything here about Kubernetes. Garden primarily works with Kubernetes, and the good news is that if you want, you can use Kubernetes YAMLs as well, but here you don't have to tell anything else, just some environment variables and the dependencies. So these are again an important part of it. So you get an abstraction. You need to write very little code. Maybe it feels like Docker Compose, so it's not very complicated. Even the documentation is quite nice, and you get this dependency management with it as well. So your deploy action with this build directive will depend on your container build, and it can depend on other actions as well, which are defined in some other folder in another Garden YAML. It works best in a monorepo where you have all your not projects but modules in the same repository in different folders. But it can work really nicely with remote repositories as well. So it can pull the Garden configuration from remote repositories. You can even tell that, hey, I want to use it, this remote repository locally. You can point it to a local directory and use it from there as well. So this is how it looks and how it feels. So it's easiest. It's really easy to use. I have a small change just here on top of the Quickstart, but it's just to use the local environment, because by default it is configured to use a so-called ephemeral environment, which is, Garden is a commercial product, so they have an open source version of their product, which everyone can use, and they have a commercial offering, a cloud product as well. We don't use it. We use the open source version, and this talk is about the open source version primarily. So as you see, if I just, this is typically Garden deploy will just run everything that is a deploy action, and all the dependencies with it. I ran the whole project, but I can run only one component, the worker. And what it does, it actually builds the image and deploys it. And if maybe it's a little bit, sorry. Yeah, so better like that. So here we are. Here are what is created under the hood are usual Kubernetes resources. So here we have the worker deployment. So what we saw there as a container module, it manifests as a worker, as a deployment. So nothing special, nothing magical is happening here. Right. Okay. Let's continue here. So the promise is that it can solve most of your problems. So you define these actions. They depend on each other. You can choose, pick one and run it. You can run all of it. You can run your tests. It has support for tests. You can deploy it to different environments. And this whole thing works in the way I showed you, as long as you just also if you run it locally, because then it uses your Docker engine to build the images and will create a reference and will pass it to your deploy actions. But if you want to run it on a remote environment, then it will Gordon will deploy a component in the cluster. Actually, a previous version deployed not just build kit or used Conico for building these images, but also deployed the registry, so that it was really easy. You just built your images, Gordon deployed it in that local registry, and all your workloads could reach the images locally, which is really nice, because when you want to iterate really fast and you have very short sprints, then you don't want to deal with this in the beginning, at least. Later, as you figured out how the product should look like and the components start to stabilize, then you will want to deal with all the production requirements and so on. Okay, so this is, again, a promise. And in case you have to deploy this stuff somewhere else where you can't leverage the registry, and in the latest release, they even removed this private registry, which is very unfortunate. But they have support for publishing these images. With a single command, you can just tell Gordon publish, give it a tag, and it will publish all your images or just the selected images to a remote registry, and you can start to use them from there. And on this picture, there's Argo CD, which is something that I will talk about a bit later, because the original promise was that is just a single tool and it solves all your problems, but it turns out that it's not quite the case. So as I already highlighted a few benefits, I tried to enumerate a few others. So it has this abstraction over Kubernetes with these container type of deploys, deploy actions, but it's not required to use this. So you can use YAML, you can write a Helm chart and deploy that. I will show how that works in a minute. And it's not just that, the order is not quite good, but it also gives you templating. So sorry for jumping to the middle, but it also gives you templating over plain Kubernetes YAMLs. So in our case, how we started, we just defined these container actions, and it turned out that it's not quite enough for one or the other use case. We soon needed Prometheus. How do you install Prometheus? You ask ChatGPT through Story. It gives you a YAML. You put it into your project, and that's it. So we could just simply add YAMLs that we needed, and it was really nice because it's a pain in the ass if you want to template it. So you either need Helm or you need Customize or something to manage these YAMLs. But Gordon helps you with this templating, which on one side it's nice, on the other it's not that nice because it's not Go templating, but Gordon is built in TypeScript, which is not bad, but the templating is not as good as we were hoping for. But it's still great enough for this type of rapid development and these rapid iterations. So it also gave us this kind of help. It manages multiple environments. As I showed, you can keep your environment's configuration in a single place. it's really easy to oversee what goes where with what kind of resource requirements and so on. This dependency management is great as well. A lot of other tools have it. It's a must to have it. Kubernetes doesn't give you much dependency management by default, so something is needed to handle it. Scaffold has it, by the way, and Terraform is one example from another area where it's also an important feature. Same here. The outputs that an action can provide are not as easy to consume from other actions, but good enough for setting up a simple project. So it was great for us for rapid prototyping, but and yes, image publish is also a nice feature as long as okay, I will talk about that in the next slide. So image publish is great on its own, but it should be a bit smarter in Garden. There are other stuff that worth to mention. Run actions, for example. So if you have one-time jobs or schema changes or stuff like that you have to manage, then you can use these run actions. You can define workflows, so you can define CI workflows and run it if you want to stay independent of a CI provider. There's built-in support for testing and for development. There's file synchronization. Again, this is something that most of the tools in this area provide as well. The biggest shortcomings that we faced. How much time I have? Okay. GitOps is not built in, so it's something that should be built in, but the YAMLs that it generates are not easily consumable. So ideally, what I would expect if I define a container module or even a Kubernetes YAML files which are templated, I would like those to be able to render them, generate them somewhere, put it into version control, and run some GitOps tool on top of it. You don't have that option. You would still have the option to just you already version control your Garden files. So you would have the option to run Garden from the CI on the actual source and Garden config, but it's not trivial as well because it doesn't handle purge. So while Helm, for example, keeps state, and if you make changes that remove resources, then Helm will help you manage that. So Helm will remove the resources for you. Argo CD will remove the resources as well if you want, but Garden doesn't support that out of the box. Okay, so and the shortcoming of the image publish is that it's not capable of building multi-architecture images, which is again a problem because then even if you build and publish those images, you won't be able to consume from the new Macs and from Linux machines at the same time with different architecture. Okay, so how we ended up using Garden is that you can see in the middle, that's the Garden icon. Garden manages or looks in the source code for the Garden config. It builds your configuration. It runs your components in Minikube locally and also in the cloud. So that's something we still leverage, although we are moving away to using Helm for these actions. That's also a possibility with Garden. So naturally, as you start with these container actions, you can move to get your Kubernetes configuration, put it in place of these container actions, then use those YAMLs instead with templating. And then when it turns out it's not enough, because you have to publish somewhere, you want to package up your configuration, and your choice to do that is Helm, for example, which is well understood in the industry. And in our case, we chose it because that's something that we can package up and give to a customer so that they can, for example, run our product on-prem. So it's not just we want to deploy it to the cloud and like software as a service and get customers there, but we also want to give it to customers so that they can run it on their own. So what we ended up doing, what I expected to do in the beginning was that Garden would magically generate Kubernetes YAMLs from all the things, the abstract or explicit stuff, and I can use that and package up. But it turned out that it can't do that easily. So what we ended up doing was that we pulled out these YAMLs. So all the generated Kubernetes YAMLs, we pulled it into a Helm chart, a single Helm chart. So a Helm chart with multiple components. And then we consumed that Helm chart from Garden. And Garden is still the tool to run and test and develop the whole thing together locally. And which is still nice, that we can use it to spin up preview environments if we have to, in case we would like to give it to a customer without them hosting it, but on our infrastructure. And we ended up not using the publish feature because of the reasons I mentioned. So we have GitHub Actions to, again, consume the source code, look at the Docker files, build the Docker images, and then Argo CD can use actually the Helm charts, and the Helm charts will pull the images. OK, so back to the Quickstart. This is a graph view. This is from Garden's cloud dashboard. They use this, so they have the open source product, but of course they would like users to use there and pay for their offering. So they only have this. You can have this preview, but of course to have this you have to send your data, your components data to them. So this is why it's just a Quickstart's preview, but it shows how your dependencies are wired together, and it's for starting, it's good for visualization. Unfortunately, later you have to you don't have this capability. You have to understand your code better to know your structure. We are very limited in time, and I'm almost running out. So probably I don't have time for much more demos. What I wanted to also highlight is that I also looked at a few alternatives. One was Acorn IO, which probably solves or its promises to solve the problem of not being able to package up the whole deployment config. So with Garden, the problem was that while we had to move to Helm because we wanted to create a package that we can give to our customers or for anyone to use. but with Garden, you can't do that. You have to ship the source code with it, so it's not possible. But with Acorn, it is. It's a similar project, but it also has an abstraction over Kubernetes, but it doesn't let you to use any Kubernetes YAMLs or Helm charts, whatever. The guys from the former Rancher folks built this, and it's a nice project. Although I haven't been able to really look into it deeply. I played around with it. It's nice, and the nice thing about it is that it builds a single image from an application which can contain multiple containers, which image actually is an OCI digest that can reference multiple images, but it packages up the whole application for you. So it packages up your images, but also the configuration of the application, which is described in a single file called the Acorn file. So all the containers and the stuff, and it requires a runtime on the Kubernetes cluster, so it's not for free. And again, they have a cloud offering so that you can leverage it. Really, last words about Scaffold. It's really very similar to Garden. Actually, it fills some gaps that Garden has. I actually created a table to compare them. It has the multi-arch image build. It has much better GitOps support, so it does what I was missing from Garden. It actually can render Kubernetes YAMLs or Helm charts for you. It doesn't have that abstraction over Kubernetes, so when you start, you have to build your Kubernetes YAMLs, but it's a very good alternative, and it was interesting because it just came out a version a year ago, a new version V2, which contains these features, the multi-arch and the GitOps, the rendering. So it's also worth a look. It was useful for me as well to get an overview of all these projects. And sorry for running out of time. I think it's now time for questions. Yes, please.
You mentioned that they have stopped the support for the repository. So is there any alternate solution for it? And also, is this support only stopped for the freeware version, or is the same in the beta?
Yeah, so the question was if Garden dropped support for the registry, and is there any alternative solution, or is that built into the public offering or the cloud offering? No, I'm not aware of any alternative solutions. So you have to configure remote registries. You want to publish Google, AWS, or your own registry. Their cloud offering contains a few nice features like these ephemeral preview environments, secret management, UI, graph view, and a lot of other stuff, but not the registry part. Okay, that's it, I guess. One more question.
So, given that it's a partially commercial product,
yeah.
If I want to build a competitor, will they switch licenses like HashiCorp did recently?
I don't know. I'm not working at Gordon. I just.
It's very question because we are at CNCF meetup, right? With the foundation of governance, and this is governed by a company.
Yeah, actually, I guess they can. So in case they want to switch licenses, then you have to be prepared to look after alternatives. So this is why these kind of I don't know, experiments are useful when you take a look at alternatives like Acorn, which is also a commercial product, but Scaffold, which is backed by Google, but it's less likely to change licenses there. So I think it's a good alternative. So we haven't, as you saw, it's better not to build too much on it. So this is why we try to keep only the local development on Garden and not the full deployment part. Yes.
Did you have a chance to try Tilt?
The question was whether I tried Tilt. No, I haven't, actually. But then that's homework for me, I guess. Yeah. No.
Me neither. It was just on my list to
Okay.
compare with these ones.
Unfortunately
Maybe
not.
somebody did my homework.
Not yet.
Anybody in the audience?
Anybody try Tilt? No one. Okay, thank you.